Section 10.1 is on simplifying square roots. One of the things you should always know is what perfect squares are. What perfect squares are numbers are there? If you square each number, those numbers that you end up with are called perfect squares. So 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, and it continues, are all perfect square numbers. When we're simplifying square roots, we are looking for those factors that are these numbers. We should know that if you take the square root of a perfect square, which is called a radicand, 25, the square root of 25 is 5, because 5 squared is 25. Find the square root of 52. Round your answer to the nearest tenth. At this point, all we're doing is we are finding the decimal value, which is not an exact answer. It's not simplified, but that's what they're asking you to do on this one. So what we're going to do is we're going to do a couple of things. We're either going to take and find the square root of 52 and approximate it, or we will type in 52 and raise it to the 0.5 power, which is exactly the same thing. If I go ahead and take the square root of 52 on the calculator, okay, so I have, I don't know if you can see this, 7.211. Or if I take 52 raised to the 0.5 power, I have the same answer. Okay? So 7 to the nearest tenth would be 7.2. One decimal place is the nearest tenth. Using the Pythagorean theorem to find the length of the hypotenuse. If I take a squared plus b squared equals c squared, and c is what I'm looking for, I know that the square root of 2 squared plus the square root of 3 squared equals c squared. Now when you square a square root, you just get the number inside. So 2 plus 3 equals c squared. So 5 equals c squared, and then we're going to take the square root. So c is equal to the square root of 5. And it says to the nearest tenth. So then you would plug it into your calculator as the square root of 5, which is 2.2. Approximately 2.2. Multiplying radicals. And then simplify if possible. Multiply the radicals. If I multiply radicals, if I take the square root of a times the square root of b, it's just whatever a times b is. So I end up with the square root of 21 right here. And that's as simplified as possible. We do not need to write the decimal. This one, if I have the square root of 2. Now, if I broke up the square root of 8, well, what I could do here in this one, I guess, is square root of 16, which of course is just 4. So that's as simple as possible. Here they listed perfect squares after the number 1. So what we're going to actually be doing here is we're going to try to find a factor of 12 that's a perfect square. We know 12 is 4 times 3. 4 is a perfect square, and that's what we look for. So that is 2 square root of 3. That is my answer. I always want to look for a factor that's a perfect square. 4 is a factor that's a perfect square, so then when I take the square root of 4, I get 2. 45, you have the square root of 9 and the square root of 5, which is 3 square root of 5. Okay, so 45 has two factors. One of them is a perfect square. Now, if you do not have factors that are perfect squares, you should always look for one in case. Now, here's a bunch of example problems. I would like to run through these with you. I would like to run through all of these with you, so I will just start and go through them so you can watch. It says here, find the square root. So the square root of 27, we would say the approximate answer is 5.2. The square root of 46 is approximately 46 raised to the 0.5 power is 6.7. The square root of 8 is approximately 8 raised to the 0.5 power is 2.9. Oh, 2.8. The square root of 97 is approximately 9.8. Now, when we multiply the square root of 3 times the square root of 5, neither one of those are perfect squares. So we get the square root of 15, and there is no factors of 15 that are perfect squares, so we leave them like that. The square root of 11 times the square root of 6, that is the square root of 66. There are no perfect square factors. The square root of 3 times the square root of 27, that is the square root of 81, which is a perfect square. It's 9 squared, so that answer would be just 9. And the last one, 5 square root of 3 times the square root of 3, these two multiply to be just 3, so you take that times 5, and you get 15. All right, the last set of problems, we're simplifying. When you look at the square root of 20, the square root of 20, does that have a perfect square factor? And yes, it does, 4. Which square root of 4 is just 2. Of course, the square root of 5 is not a perfect square, so we leave it like that. The square root of 8 is also 4, but this time times the square root of 2, so that's 2 square root of 2. The square root of 75. 25 is a perfect square that goes into 75, so that's 5 square root of 3. 112. Okay, let's try it. Let's see. Does 4 go into 112? 112 divided by 4 is 28. Let's see if 16 goes into 112. It does, 17 times. So this one is the square root of 16 times square root of 7, or 4 square root of 7. And that is how you simplify radicals.